Okay, our first chapter, functions and their graphs. Okay, here we are going to discuss about definition of a function and definition of graph. First, just recall what we have studied about functions in previous classes. Okay, let us take, here they have given some examples. F of x equal to root of minus x, root x plus 1 if x less than 0 and x greater than equal to 0. How can we find f of minus 4, f of 0 and f of 9? It is very clear that as per the definition, here x equal to minus 4 which is less than 0. The function value will be root of minus x. That is, we replace x by minus 4. That is minus of minus 4, and the value will be equal to 2. Okay. And if f of 0, the function value is defined as this one. That is root x plus 1 if x greater than equal to 0. That is, the value will be f of 0 will be equal to 1. Now f of 9. In the case of f of 9, the value will be same as this, that is root 9 plus 1, that is equal to 3 plus 1 equal to 4. Now think about what happens with the next question. Find and simplify f of x plus x minus f of x by h. F of x equal to x square plus 2x. F of x equal to x square plus 2x. We have to find f of x plus h minus f of x divided by h. That is f of x plus h equal to x plus h whole square plus 2 into x plus h. That is, we can use the formula a plus b whole square, a square plus 2ab plus b square. Then here it will be x square plus 2xh plus h square plus 2x plus 2h. F of x equal to x square plus 2x. So when we minus f of x plus h minus f of x, f of x equal to, it will cancel out x square terms, 2x terms, and the remaining will be 2xh plus h square by plus 2h. When we divided whole divided by h, the h will be cancelled from each one of them. Then it will be 2x plus 2 plus h. Now let's discuss next problem. Find the domain of f of x. To say about domain, first we must understand what is the definition of a function. Okay, f from a map f from set a non-empty set A to a non-empty set B. That is, non-empty means A not equal to 5 and B not equal to the empty set, that is 5. From A to B we have function. Then for every element of A, let us consider A equal to A, B, C, and let B equal to, this is A, my B equal to let 1 comma 2. We say that a function f from here to here, we have to map every element of A to B first. So we can map it several ways. We can map A goes to 1, B goes to 2, C goes to 3. This is a function. Okay. The same time we can map A, B, C to 1, 2 as A goes to 1, A goes to 2, B goes to 1, C goes to 2. what is the difference between these two pictures or these two mappings? In the first one, we are mapping each element of A to a unique element of B. Okay, that is A is mapped to 1 and B mapped to 2 and C mapped to 2. In the second one, in this one, what happens? We have mapped A to two elements. We have mapped A to 1 and A mapped to 2. That is not a function then. Okay, so we can define function as in this manner. A function f from a set A to a set B is a rule that assigns to each element of x in A one and only one element y in B. That is, for every element of A, there exists a unique element in B such that that particular element in X, A will be mapped to an element in B. So let us consider some examples of functions. If we are drawing some these diagrams, then we can do like 1, 2, 3. Let it be A, B, C. Then this is a function. Or 1, 2, 3. A, B, C. 1. This is also a function. Okay. So if a function from this is set A, this is set B, then the set A where the function starts is called the domain of the function. That is the domain of f. And the points where the elements in A are mapped is called the image of f. Okay, so here in the first function, the image is set A, B, C. In this function, if it is function 1, f1, then the image will be only A, because here 1, 2 and 3 is mapped to only A. There is no pre-image for B and C. Okay. Here we are explaining once more what is a function. A function f from a set A to B is a rule that assigns to each element x in A one and only one element y in B. Okay. The set A where the starting stage is called the domain of a function and the element y in B is called the value of f at x. Okay, or f evaluated at x, or we call it as f of x. And the set of values where y equal to f of x as x varies over the domain of f is called the range of f. So the definition of range of f is f is a function from A to B, then it is set of all f of x such that x belongs to A. That is, we will take values of f at each point of x in A and we collect them together, then it's called the range of f. If A and B are subsets of real numbers, then both x and f of x are called real numbers. Also real numbers, then f is called the real valued function of real variable. Okay. Now consider a machine like this manner. Here x is the input, and so we are explaining function as in some another manner. So x is the, suppose x is our input and f the function is the processor, and f of x what we get is the output. Okay. While we are defining function, we have to define the function properly first. Okay. Now consider the function f of x equal to root x. Is there any problem with root x? Since we know that root 4 equal to both 2 and minus 2. So when we consider this function, 4 will be mapped to both 2 and 4 will be mapped to minus 2. But that is not possible for a function. For a function, for every element of A will be mapped to one and only one element in B. So while considering function f of x equal to root x, we must take only positive roots. Okay, we will take only positive roots. Okay. What is the another problem with f of x equal to root x? Usually when if we not define the domain particularly, we will take the domain as a equal to r, the real numbers. Okay. So when in the case of f of x equal to root x, root is only defined for positive values and 0. So there is a problem when x equal to negative numbers. Let example, let n x equal to minus 4, the root of minus 4 is not defined. That is, root of negative numbers is not defined. So when we consider f of x equal to root x, we should not consider the negative values of x. Then for the function f of x equal to root x, the domain will be domain equal to r minus, or we can take it as it is closed 0 to infinity. That is, we will only consider positive real numbers and 0. So when the drawing a picture, we can say draw like this. This is what function the domain from A and f map to B. B will be the full set and we will call it as codomain. B is codomain and this is our range. So from clear the picture, it is clear that range is a subset of codomain. Okay. So let us take example. Consider another the same example what we have discussed on A, B, C, and we mapped this one in this manner. Then the range of f will be, if f is the map from A to B, then the range of f equal to set of all f of x such that x belongs to A, that is equal to A and B. Okay, and the codomain is B. So clearly range of f is a subset or equal to B. Okay. Here they are considering an example of function y equal to root x. F of x equal to root x is just a square root function mentioned earlier. That is, we will consider only the positive roots. Okay. Then n x equal to 16, it will root x. F of x equal to f of 16 equal to f of root 16 equal to 4 we will get. And the range of f will be positive real numbers also. Why is the reason? Why we are getting like that? Because when t element of closed interval 0 comma infinity, we can take root t, or we can consider the t square corresponding to that, and the t square will be again belong to 0 comma infinity, and we will take the root of t square, we will get t back. That is, every t element of closed interval 0 comma infinity, we will get a pre-image. That is, closed interval 0 infinity is its image. For every non-negative number, we can take the root of that number. So closed 0 comma infinity is the domain and the range of f of x equal to root x. Now here we are considering the function as y equal to f of x. So x is called the independent variable. Here we can choose any x. So there is we have the choice of x, it is independent, and the value of y is dependent on x. That is, we, as per definition, y equal to f of x. So x is independent, y is independent of the value of x. So x is the independent variable and y is the dependent variable. Now evaluating functions. How will we evaluate the function? Okay, how we will evaluate the function? In the function, what we do is we replace x by the point value. Easily explaining by this example. Here f of x equal to x square plus 2x minus 1. Okay, how can we find f of minus 1? What we do, we will replace x equal to minus 1 in this function, that is minus 1 whole square plus 2 into minus 1 minus 1, that is equal to 1 minus 2 minus 1 equal to 0. Here 1 minus 1 minus 2 minus 1 minus 2. Okay, we are getting this minus minus, it is minus 2 we will get, not 0, minus 2. Okay, so this is the way we find the value, evaluate that point, particular point. To evaluate a function at particular point, we replace x by the value, the particular point itself. Here f of minus 1, what we will do, replace x by minus 1. In the f of pi, what we do, replace x by pi. Here replace x by t. Here replace x by x plus h, and here replace x by 2x. Finding the domain of a function. Okay, now we have to find the domain of particular functions. Here there is an example. F of x equal to 2x plus 1 divided by x square minus x minus 2. What is the problem with this particular function? When let's look at this function. F of x equal to, what is the function? 2x plus 1 by divided by root of divided by x square minus x minus 2. When we are writing a function like this way, f of x by g of x, surely if the g of x should be not equal to 0. If g of x comes 0, then it will be f of x by some 0, then the function is not defined. Okay, so we should avoid the denominator to be 0. So in this case, here the denominator is x square minus x minus 2. So we have to find the points where x square minus x minus 2 is 0 and remove that points from the domain. So what are the points? X square minus x minus 2 can be written as x minus 1 into x plus 1 into x minus 2, x plus 1 into x minus 2. Okay, so we have to remove these 2 points. When x equal to 1, this is so these points we have to avoid, which are the points x equal to minus 1 and x equal to 2. In these 2 points, the denominator will be 0. When the denominator is 0, the function will not be defined. So we have to remove then the domain will be remove minus 1 and 2, that is r minus minus 1 comma 2. That is our domain, or we can write it in this way: minus infinity to minus 1 union minus 1 to 2 union 2 to infinity. Okay, this is the domain of that particular function. Now look at the another function, f of x equal to x plus root x plus 1 divided by 2x minus 1. Here what are the problems? First, identify where the function is defined or where the function cannot be defined. Here two issues are arising. First one is function is x plus root x plus 1 divided by 2x minus 1. Here the first issue is we have to remove the point where the denominator is 0. If denominator is 0, the function is not defined. So clearly that is the point when 2x minus 1 equal to 0, that implies x equal to 1 by 2. Okay, is it over? Is there any other issues particularly regarding this function? Look at here, this is root x plus 1. The root value must be inside the root, the value must be greater than or equal to 0. So x plus 1 should be greater than or equal to 0. That is x greater than or equal to minus 1. So what we get, the domain will be, must satisfies the condition 1, x must be greater than or equal to minus 1 and x should not be equal to 1 by 2. So the domain will be minus infinity to closed interval minus 1 union minus 1 to open 2 union open 1 to infinity will be the domain of the particular function. Okay, here there's a mistake is there. What happened? Here we cannot take x greater than or equal, x must be greater than or equal to minus 1. When x greater than or equal to minus 1, it will start from where only? It is minus infinity to minus 1, you have to remove that. This is not possible. Okay, when x is less than minus 1, there will be negative value coming inside root. So this is not correct. So the value will be x is greater than or equal to minus 1. So should be minus 1 to some infinity and x should not be equal to 1 by 2. So the domain will be minus 1 to 1 by 2 union 1 by 2 to infinity. Now we are going to say what is the graph of a function. Okay, this is something very similar to us and familiar to us. What was that? Graph of a function. How you draw the graph of function? What we do is we plot x values and y values. We plot x axis and y axis. X axis, this is our y axis. We plot the points of x and corresponding values of y, that is x comma x of f of x will be plotted, and we will, if there is a point, then we will draw accordingly through that lines, or through the, we will draw a line or the curve through that points. So there is some uncertainty is there about drawing of the particular graph, about the shape and everything, that we will see after 2 modules. We will understand how can we draw a graph y equal to f of x properly. So graph of a function is the set of all points of x comma y such that y equal to f of x where x lies in the domain of f.